Hi everyone, welcome back to MATA02, the magic of numbers. I see you guys have decided to join me for at least second class, and today we're going to be So last time we spent some time inventing counting and inventing summation, and really just going into how a mathematician develops those ideas. Today, we're going to continue with that, and we're going to talk about the number line. We're going to talk about how to invent multiplication, division, and fractions. So you guys have all seen that before, but we're going to take it from a sort of first principles approach. So if you hadn't ever learned those things in school, how would you try to develop those things? Why would you try to develop those things? And how do those things, why do they make sense? Are they just some arbitrary set of rules that some teacher throws at you and says, memorize all these, run this particular series of steps? Well, yes, they are, but they're a lot more than that. And that's what this course is really trying to convey. So today we're going to talk about the number line. So that'll be the first third of today's lecture. And so last time we left off by saying, well, we still had a problem that remained after inventing negative numbers, right? If I remember correctly, I actually shouldn't have reset my chat response. But the answer here was really all of the above. And the reason for that is, well, we don't know how to subtract negative numbers because we haven't defined that. We defined subtraction only for positive numbers. So what is negative 4 minus negative 3? Well, you guys may remember how to do that from your school days, but that's not really something we've invented yet. We also haven't invented adding negative numbers, so negative 4 plus negative 3. We just haven't invented these things yet. Or things like how subtraction and addition interact. And so for this reason, we're going to talk about something called the number line. So notice that we can arrange the positive numbers on a line. It's sort of what we're doing already when we're writing out the numbers one by one, right? Are we back? Okay, great. So, where was I? Actually my Zoom, that's also going to be broken. So let's fix that as well. Let's save chat. And okay, so we are properly back up and running now. So let's, I will scrub that from the recording for anyone who's watching this on YouTube. But anyway, so when we're on a positive number line, you can sort of think of addition as moving to the right and subtraction as moving to the left, right? So you can think of addition as summing together the number of steps you've moved right, and then subtraction as taking away steps you've moved right or moving to the left. And so now this is one nice way of arranging the numbers, because if you arrange the positive numbers this way, then that gives you a rule for how addition and subtraction interact with each other. You're just moving steps to the left or moving steps to the right. Sorry, I'm mirrored. Moving steps to the right or moving steps to the left. But now, then the question is, we also invented negative numbers last time, right? So where do the negative numbers go? So there are a couple different things you could do. But now, if we just think about the negative numbers as a copy of the positive numbers, and don't talk about how the two interact with each other. So they should behave the same, right? So we can create a copy of the negative numbers and just say, well, what if we have a 0 here, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Well, then you should be able to do the same sort of thing with negative numbers that you did with positive numbers, right? So 0 plus minus 3 would be the same as going from here, 1, 2, 3. So this is plus minus 3. And then if you go into another 2, that's plus minus 2. And maybe we can subtract something as well. So maybe we subtract, say, minus 4. And then you go the other direction, 2, 3, 4. Because all we're doing is we just added this label, this minus sign label. And this ends up giving you is equal to -1. Okay, so now we haven't done anything interesting here. All we've done is we've exactly copied what we did with the positive number line, and we just said, well, maybe we can make a copy of the, since we made a copy of the numbers, then we should make a copy of the number line. So that's what we did, but now, of course, now we have to combine the two lines. And now that is a question that I'm going to ask you all. So how do you combine these two number lines? So can we, well, A, can we combine them? If so, how? So I have a couple options here, so please vote in the chat. Should we stack them on top of each other? Should we put them side by side? Should we put them side by side but flip one? Should we make one horizontal and one vertical? Or can we not combine them? Okay, so let's see what people are thinking. Okay, so a lot of people, so this is in some sense something that you guys, many of you guys have already seen before, right? So you've probably seen the number line before where you have one going, the positive numbers going off one way and the negative numbers going off the other way. There are a couple other suggestions. One is to put them side by side, which is sort of the same, but then you run into the question of when you put them side by side, what they both go off infinitely. So like where do you start one? If you flip one the opposite direction, then it makes sense. And a couple of people are suggesting one horizontal and one vertical. So for reasons that will become clear in a moment, this is actually not what we do for the positive and negative numbers, but that is something you do for complex numbers, which might be where you're thinking of that. So sometimes when we connect together number lines, we will be putting one vertical and one horizontal, but not in this case. So now the next question is, what facts can we use to allow these things to combine together? So let me reset this. So when I say what facts can we use, well, we have to somehow merge these two lines. So you might be able to use multiple things of this list. So there are multiple things on here that are correct. You can only vote for one, though. So what facts can we use to combine them together? Can we use the position of the 0, which is shared between the two, the definition of subtraction, the fact that they're copies, or maybe using some extra dimensions, or none of the above? So let's see. What are people thinking? Oh, okay. So a lot of people think that you're using the position of the 0. Which I will say is one of the things you can use. But while we're at it, so I will just tell you that A is one of the answers. There is another one of these things that is a very important answer. So why don't you guys switch to the other one. See if you can guess what the other one is. Okay, so we're getting a bunch of C's, a few D's, a few A's. Okay. So the other one's a little bit more subtle, and the reason for that we need one of the other ones is, well, we've already sort of used the fact that there are copies to have two of them. But you have to be a little bit careful, because if you're just using the position of the 0, well, what if you do this? 1, 0, 1, 2, 3, 4, and so on. Well, the negative numbers have to connect, so they have to start at 0, but you could go at 0, -1, -2, -3, -4. And somehow that isn't what we want. And there's a reason for this. And the reason for this is our definition of subtraction, actually. So part B, because we've defined subtraction as going left and going right. But if we want subtraction to make sense for negative numbers, then you really need to put it on the other side to the left. And yes, of course, we are using the fact that they're copies, and we aren't actually using extra dimensions for this particular part of the construction of the number line. So now let's see what I mean by that. So let's go over to the number line. Remember, 0 is present in both lines, and subtraction of two positive numbers can give a negative number. So what that means is, if we have this number line, so if we have this number line, let's say 0, 1, 2, 3, 4. Oh, boy, what just happened? 4. And so on. And we then go the opposite direction, and we have, say, well, the 0 appears in both of them, so let's put that in green. 0, -1, -2, -3, -4, and so on. Okay, so once we've done that, well, remember, the way that we want subtraction to be moving to the left and addition to be moving to the right. for at least the positive numbers. But what is, say, 2 minus 3? So 2 minus 3, remember, we defined subtraction as negative of the flip of it when we were defining these things. Because 2 minus 3 doesn't really make sense for positive numbers. What does it mean to take 3 things away from 2? And so the way we defined it was we invented these new numbers, and then we defined it by flipping the order of the subtraction and adding a negative sign in front. So this is equal to minus 1. So what do we mean by that? We mean that when we're going from 2, we're going to move left 3. 1, 2, 3. And that's where the minus 1 should be, and so that's why we put the minus 1 there. But you can keep on going. So one thing you might notice is that, well, 3 minus 4 gets to you want to get to the same place. That's minus 4 minus 3, which is also minus 1. So that's 1, 2, 3, 4. On the other hand, we could have things like 1 minus 3, which is minus 3 minus 1, which is equal to minus 2. So that's 1, 2, 3. And so because we want subtraction to make sense, so we want subtraction on the positive line to be moving to the left, but we want it to be moving to the left on the entire line, because that's just a nice way of continuing things. So when we do that, that actually forces us to position every one of the integers, every one of the negative numbers, over on the same line, but just going to the left. And you can sort of see this because if you just take 1 minus all of these different things, you get 1 minus minus 4 minus 1, which is equal to minus 3. So 1, 2, 3, 4. And you can keep on doing this. And so this actually forces the position of every single one of the negative numbers as just to the left going on. Does that sort of make sense to everyone? So basically what we wanted to do is we had this definition of addition and subtraction. We wanted addition to be moving to the right, subtraction to be moving to the left. And and if we want that to be consistent, if you want subtraction giving negative numbers to also be moving to the left, then you're forced to flip it in the way that we did. And so this is why it's just one single number line instead of, say, one line going horizontal and one line going vertical, because we want this definition of subtraction to be consistent across the entire line. And this gives us a couple other nice properties. So for example, if we write it this way, let me actually draw this out since, so if we draw it this way and we actually draw a line, well, we have our 0 point, and then we have 1, 2, 3, 4, and going the other way, minus 1, minus 2, minus 3, minus 4. Like we were saying earlier, another way to understand addition of positive numbers is how far to the right we're moving. So I'm just repeating myself here, but this is one of the basic important concepts. So 2 plus 3 is equal to move right 2, then move right 3. And we always start at the 0 point. We can also think of this as a counting problem. So if this arrow is a right move, then we're counting the number of arrows. So 1, 2, and let's say put this in a different color, 3, 4, 5. I don't know why I have this little mark here. There. Oh, erase that. And another way of understanding negative numbers is by moving to the left on the number line. So if you think about it, if we want to add negative numbers, so on the negative number line, when we're adding negative numbers together, we're making them more negative. But now that we flip the negative number line, when we add negative numbers, that means we're moving to the left, because moving to the left is moving more negative. And so you can understand that the same sort of way. But you can understand that for both, say, minus 3 plus minus 2 is equal to minus 5, because or you can think about it in terms of, say, a positive number plus a negative number, because all you're doing is you're doing a move along the number line. So this is equal to move, let me write that properly. So this is move right 3, and then move left 5. And subtraction then means to move in the opposite direction of an addition, or to add the negative of a number. And so what we've seen is that by inventing this idea of a number line and defining things in terms of moving right or moving left along that number line, you are the sort of interaction between addition and subtraction becomes obvious, as well as how negative numbers work. And so somehow negative numbers are negatives are the opposite of positives, as you probably already knew. But this is just sort of, we're in the process of reinventing math. Okay, and there's another major way that you can use these. Sorry, were there any questions on that? I don't want to go too fast. So all this would be stuff you know, but I'm hoping that this gives you some better intuition for why people like invented negative numbers in this way. Okay, so let's move on a little bit. So let's talk about lengths and the positive number line. So one way positive numbers are used is to measure lengths. So suppose that we have a flagpole here. So I did warn you that my drawing skills are not very good, but suppose we have a flagpole here. And what we're interested in is we're interested in how far away are we from the flagpole. Well, one way of doing that is we have this big long line now. And so we haven't decided exactly what the distance between a 0 and a 1 or a 1 and a 2 is, but once you set a particular distance, say 1 meter, then you can put down a big version of the number line, and put a 0 at where the flagpole is, and then let's say these are meter lengths. 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. But now you have to be a little bit careful because yes, you have to be a little bit careful because even though this works for the positive number line, if you go the other direction from the flagpole, you're still only distance 1 away. So really, this sort of when we're measuring distances like away from something, there isn't some concept of negative numbers. Like you still can have that concept like going backwards once you define some direction as the main direction, but until you define a direction, you don't have that. But so now, I can walk, if I walk 3 meters away, so 3 meters, let's say this is meters from flagpole. Then, I'm over here, and then I can walk another 2 meters, and somehow the number line allows us to count the number of meters I am away from the flagpole. And there are a couple of issues with this. One is that, if you want to make negative numbers make more sense, you still can go backwards, of course, and that sort of corresponds to negative numbers. But it helps a lot if you define a particular direction, let's say going right as the positive direction, and then what you can do is then you can use negative numbers and make that an actual negative. It's important to remember, however, that right now we only have whole number increments. So we haven't invented anything other than 0, 1, 2, 3, 4, 5, and 0, -1, -2, -3 going the other direction. Those are the only things we've invented. So we haven't really invented the idea of something being, say, negative 0.5 meters or positive 2/3 meters. Those aren't things we've invented yet, though we'll get there. Okay, so now, let's have you all think like a mathematician. And I've already sort of given away some of what I'm going to be talking about. So now we were measuring distances a moment ago. You can also use this to, measure lengths of things. So when you want to think like a mathematician, there are several things you should be thinking about. One of the first things is mathematicians really like looking at problems you've already solved. So if a mathematician has already solved one problem, then if you can turn a new problem into that problem they've already solved, then they can solve that new problem as well. And this is a big part of the job of a mathematician, is realizing that two problems, which look slightly different, are actually the same thing. So if you remember back to the very, very basic example of counting, with counting, it was realizing that counting apples is the same idea as counting oranges. You can't compare apples to oranges, but if you're just counting them, you can compare the counts of apples to the counts of oranges. And so now, let's say that we want to measure the length of a rope by assigning a number on the positive number line. Well, one of the first things you might think is, we know how to assign the distance from a flagpole, because that's what we just did in the last slide. So that's what we did there. But somehow, that sort of idea of measuring length is a lot more general than just measuring distance from a flagpole and putting down a number line. Instead, you can use it for all kinds of lengths. Let me ask, what lengths do we know how to compute so far? Or actually, let me say what lengths don't. Let's say what lengths do we know how to compute so far? And there might be several answers here. So let's say which of these 4 options or 5 options is the first one. So if you think we don't know how to compute any of these lengths, then you should pick E. But otherwise, pick the very first of the ones that you think we know how to do. So do we know how to measure the length of cutting a rope in half? Let's see. How are people voting? Okay, so we have a number of B's and we have a number of D's. Okay. So it looks like you guys have a pretty good understanding of what I mean by what do we know how to do. Because cutting a rope in half, well, what does a half mean? We haven't invented halves yet. All we've invented is whole numbers, like we were saying. And so there's no sense of what it means to cut a rope in half. So it's not, come on, go back. So it's not this one, joining together 2 ropes. Well, we know how to do that because it's just adding together the 2 lengths. And so B is a correct answer. But what about joining together 1,000 ropes? So yes, in theory, like you could just add together numbers 1,000 times, but that's not something we really know how to directly compute, especially, and there are faster ways of doing that. So, which we'll learn later when we learn multiplication. Or sorry, not learn multiplication, we're inventing multiplication here. And so that's also not something we're going to be doing, although we'll get to that in a moment. And yes, you can, in theory, compute that by just adding all 1,000 ropes together. So I'll put a question mark here. But D is correct. We know how to cut a piece of known length off the rope and measure the remainder, because that is just subtraction. So this here is just addition, and this here is just subtraction. And note that this here is going to require us to understand something like division, and this here is related to multiplication, especially if the ropes are the same length. So we'll get to that in the other parts of the lecture. So, but before we finish off with talking about the number line, I wanted to spend some time and just give you a teaser for week 6. So you'll notice that we made a choice to invent the negative numbers, right? So somehow in the last lecture, we spent some time and we're like, well, what does it mean for us to have negative numbers? And the reason we invented negative numbers is we wanted to be able to do subtraction, right? So the problem with only having positive numbers is if you subtract 3 from 2, that doesn't make sense. But what if instead of making a copy of the numbers, now we have this idea of a number line, what if we turn the number line into a number circle? And this will be the basis for something we are going to call clock arithmetic or modular arithmetic. And this is going to be a sort of funky concept to understand, so don't worry if you don't fully understand it now. So I don't know how many of you guys have seen analog clocks. I know I'm dating myself a bit. So digital clocks are obviously a great invention, or you guys can just use your phones. But you guys are probably seeing these old clocks with like the minute and the hour hands moving around in circles, right? You're not that young. Well, I don't know how young you guys are. It's sometimes hard for me to tell. So you guys have seen these clocks before, and if you think about it, well, one of the things you could do is you can, if you imagine the 12 as a 0, so let's call a 12 a 0 for now, just to make life easier, and we're drawing them around. You start at 0, and then, let's see, let me try to get this. Okay. So you have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and we're going to call 0, 12 for the sake of simplicity. And one of the things is you'll notice that this number line, we not only got rid of the negative numbers, we got rid of most of the numbers. So we only have a very few numbers here. But the nice thing is, once we've defined the number line, and defined addition and subtraction by moving to the right and moving to the left, then all of a sudden, we can have some idea of what addition and subtraction mean. So in this example, we could say that moving to the right from the top, or moving clockwise, since that's the direction clocks go, is going to be addition, and moving the other way is going to be a minus. So you might say something like 0 minus 1, so that's moving 1 to the left is going to be 11. Or you might say that, say 11 plus 2 is going to be equal to 1. And so this is really weird, right? But it sort of makes sense if you think about addition and subtraction as moving to the left or moving to the right, or in this case, moving along the clock in one direction or along the clock in the other direction. And it turns out that you can create an entirely new type of arithmetic based off of this sort of idea. So the normal way we make sure subtraction always works is we invented negative numbers. But it turns out in some specific settings, instead of inventing the negative numbers, we instead just like turn it around, cut off most of the numbers, and put them in a big circle. And there are other sort of shapes that we can like turn the number line into, that also where we can still make sense of the idea of what it means to add and subtract. And so that's going to be something that we discussed in week 6, is just these different ways of inventing numbers. Yeah, so any questions on that? Okay, great. So with that, I will end this first part of the lecture. So let's give you guys a 5-minute break while I work through switching my slides and make sure nothing goes wrong.